on the PhET system dealing with gravity. So everybody should get that sheet out. You don't need your phones out right now, but you do need that sheet out so we can talk through it. I asked for you by the end of, well, I guess by today now, to have gone through the back all the way through question 4. So that is what I expected you to be at. That's where I'm hoping that you got to, because that's where we are going to work from today. Okay? I know that it's springtime. I know that you have a lot going on. I totally get it, because I'm living it too. I totally get it. What I'm asking of you is to make sure that while you're in class with me, you're here 100%. You're focused on physics. And I don't ask you to do a lot of stuff outside of class. So I'm going to ask that you really do those things that I'm asking you to do so that we can get through so that when you take your quizzes and tests towards the end of this year, you can have success. Okay? So please make sure that you're staying focused. Please make sure that you're with me. Okay? Right now you are. Here we go. So in question 4, the thing that I had asked you to do for today, I asked you to figure out a proportionality for Fg as it relates to mass 1, mass 2, and the distance I'm marking at r. What kind of a proportionality did you come up with? Please be honest with me. Did you try it? Okay.
I didn't really get it.
Okay, that's what I'm asking. Did you try it? That's the question, right? So yes, I did try. Okay, let's back up. So I don't like to be this person. I'm gonna be completely honest with you guys. I blew up at one of my 9th grade classes yesterday, and I was talking to one of the kids who got mad at me as a result. And he said, "This is not how you are, Miss Kay." And I said, "I know. But here's the thing. The reason that I got upset was because people were not listening. And I'm not there with you guys right now. But at the same time, I need you to try with me, okay? I need you to put in a little bit of time. We're going to back up because it's important that you know this. But if I need to start giving you a quiz every day at the beginning of class to make sure that you're there, like Madeline's giving me this evil eye, like you wouldn't do that, would you? Personality, friends, do I want to do that? Heck no. But I do want you to come into class every day ready to go and ready to work, right? Every day until May 22nd or until May 31st, right? Like I need you to be with me. Okay, we're going to back up. I need this commitment, or I will. I'm happy to write quizzes. A question a day. I can do that. We can go back to adding up points. Makes my heart hurt a little bit. I can do it if you need me to. Question 2. Look at that one right now. Why don't you pull out your simulation right now? Get those Chromebooks out. If you haven't answered question 2 and question 3, we're going to go through it right now. Everybody get your Chromebook out right now, please. Open up to the PhET simulator right now, please. I want you to close all the papers you're writing. I want you to close all the emails. I want you to close Google Chat. I want you to just have the PhET simulator open. Okay? I want you to figure out the answer to question 2. Question 2 says, what is the relationship between the mass and the force? And not just that as mass goes up, force goes up, because you did that a while ago. That was on the front. I want you to be specific. There are 2 steps here to help you. What happens to the force if you double the mass? Be specific. I want everybody to do it. What happens to the force if you triple the mass? Write it down and be specific. Go through steps 2 and 3 right now if you haven't done it. If you're not sure what to do, talk to your neighbor. If you're not sure what to do, let me know and I'll help you. I want you to understand this. This is the process of physics. Plugging numbers into equations, you can do that in math class. I want you to understand this. That's why we're here. All right. So let's go through this just really quickly here to make sure that we're understanding this. Because if you don't get this foundation, then the rest of it doesn't make a lot of sense. So what happens to the force if you double the mass? What did you find? It doubles. So 2m results in 2f. What happens if you triple the mass? What happens to the force? It triples. It's like a pattern. If you make it 3 times m, you get 3 times f. It's interesting. Fg is proportional to mass, right? It's proportional to the red mass and the blue mass. It's proportional to both of them together. Did anybody try to double one and triple the other, do both at the same time?
Yes.
It's wild and crazy. What happened to it?
Goes up 6 times.
Whoa, right? So it's proportional to one mass and to the other mass. So I could write this as M1 and M2 put together. Because if I increase this mass by 6 times, then Jacob says that this increases by 6 times. Okay? So it doesn't matter which one, but it's all proportional. Step 3 is a little bit different, right? If I triple the distance between the objects, so if I get 3d, what happens to FG? Does it go up? Does it triple also?
No.
It does not. Does it go down by 3? It's not a third the size. How big is it?
A ninth of the size.
Do you guys agree with him? He's loud sometimes. Want to make sure we agree with him. Then he shakes his head yes. Like, of course I agree with myself. Do you guys agree with that? Does that make sense to you? How would you figure that out? How would you make sure that you agree?
Do it yourself.
What are you going to do, though? What's the it?
Triple the distance.
Triple the distance, and then compare the force, right? And it does happen to be 1/9 the size. What happens if you do half the distance? Jacob's not allowed to say it this time. If I do half the distance, what happens to the force? It goes up. Does it double? Do it right now. Whatever you're doing, do it right now. So take the distance, note that force, and then move them closer so that they're at half the distance that they were before. What happens to the force, friends? Don't rely on the loud kid. The loud kid isn't always right, and the loud kid isn't always there. You've got to be confident yourself. Okay? The force goes up, doesn't it? But by how much does it go up? Talk at your tables at least. Come on. You guys have to do this. Yeah. What'd you get, Madeline? Is it 9 times as big? It's a lot. How much is it? How do you figure it out? This is what I want to make sure you know how to do. Even if you're not going to become an astrophysicist, you still need to know how to compare numbers, right? So you got your force, your original force, and you've got your new force. And you want to figure out what the difference is there, right? So you divide them. Fn divided by Fi, what's the number? Or in this case, yeah, because this one's bigger, right? What's the difference? How much does it go up? 4 times. 4 times it goes up. It's 4 times bigger. So if I take that initial force and I have the distance between them, the force goes up by 4 times. This ratio is a big deal. It's a big deal. There'll probably be a question like this coming up soon that you'll see, that you'll want to understand and make sure you got this. So if you need to put a big star by this so that you actually go back and look at it tonight to make sure that you get it, then I would do that. Okay? I'm going to keep cruising though because I want to make sure that we can get there, get where we're going. So part A says 3D gives you 1/9 of FG. Part B says 1/2 of D gives you 4 times FG. What's the pattern that you might be able to find from those two pieces of data?
1 over D squared.
1 over D squared. Where do you get that from?
If you take the square root of both of them and then put them over 1, it gives you the 3 or the half.
So I take the square root of 9. Square root of 9 is 3, right? And then it's 1 over that thing. If I take the square root of 4, square root of 4 is 2. 1 over that gives me 1/2. That's where this thing is coming from. The force of gravity between two objects some distance away from each other is proportional to the distance squared between them. That means the closer you get, the bigger that force gets, and that force gets bigger faster than the distance gets small. I'm going to take this thing here, Fg is proportional 1 over m times m, and this one here, Fg is proportional to, 1 over d squared, and put them together. All I'm doing is writing them together. Here we go. You're going to write this with me if you haven't done it already on your paper. m1, m2 over d squared. This right here is one of the 2 reasons that Isaac Newton is famous. He is the first person to figure this out. Or to articulate it, I should say. To write it down. I'm not very impressed with this, though, because it's just a proportionality. What does proportional to mean? Anybody know? Yeah.
In relation to?
In relation to, right? So as m1, m2 over d squared goes up, this thing goes up. And it goes up by the same amount every time. So we could say instead, we could write this as Fg, I want you to write this down too, is equal to some constant times m1, m2 over d squared. But in order to make this equal, I need to know this constant. You're going to help me find this constant right now. Okay? Now, this is what we're going to do. I put on Canvas a link to a Google Sheet. Okay? And on that Google Sheet, I'll show you where it is. On that Google Sheet, it says Gravitational Force Sheet. When you go there, there are 2 columns, or 3 columns actually. One is the force, and one is mass 1 times mass 2 divided by distance squared. Okay? So I would like for you to go to the PhET simulation. And I would like for you to write down a force. So the force that you're looking for is this little tiny number here. And you're going to take your 2 masses and the distance between the objects. So pick some mass, pick some distance, and then calculate m1 times m2 divided by d squared. And I would like you to put that in my sheet here, okay? And then put your name right next to it just so that we know whose is there. All right? I'm going to give you just a couple minutes to work on that. Every person needs to do it. So I'm looking for One per person up on the Google Sheet. Okay? I want to explain to you what we're going to do with this. So you have now populated a column with FGs, right? Mm-hmm. And you have now populated a column with M1, M2 over D squareds. I want to know the constant of proportionality between them. So a really nice, easy way to figure out that constant of proportionality is to be like, oh my gosh, look at this. Holy cow. Are you with me there? It looks like y equals mx plus b, except there's no b. So if I graph FG on the y-axis, and I graph M1, M2 over D squared on the x-axis, then where is my constant of proportionality going to be? In the what? The slope. The slope. So we're going to try this. Now, Google Sheets, as we know, is sometimes a little crabby, but we'll see how we do. You know, adventure. Nothing like trying things out right in front of everybody, right? All right, here we go. We're going to insert a chart. There's no data, but I don't want a column chart anyway. Give me a scatter plot, please. I want all of this data. Oh, my mouse is crabby. I feel like I need some like working music. Like it would be more exciting. All right, here we go. Our x-axis. What do we want on our x-axis? Do you remember? What did we want on there? The big mess, right? Big mess goes on the x-axis. So that's going to be that stuff. And then on the y-axis, we're going to edit, because right now it's just a straight line of nothing. We're going to put these guys in. Cross your fingers, friends. That's pretty linear. Looks like maybe there's one off. Let's make sure we did this right. So we've got B on our x-axis and A on our y-axis. That's pretty lovely. I'm not going to take the time to make all of the labels, but we could do it in our brains, right? This is the M1, M2 over R squared over here. This is the force. And the slope of this line then should be our constant of proportionality. So we're going to go ahead and get that trend line, and we're going to get that equation. Ha-ha! This number is pretty darn little. 6.69 times 10 to the negative 11th. Now, if we think about that, and we look at the equation that we had before, we were saying this thing here, and these were pretty big numbers that you typed in, right? Like hundreds or thousands. And then these numbers, were they really big or really small?
Really small.
Really, really small. Which means that there's got to be something really, really small here to give us a small value for our force. You with me there? Okay. Now, there was one, I think, value there that was not quite on. That may have messed us up a little bit. The actual value, and this is what you're going to write down in your sheet. It's actually question 7. We kind of skipped question 5, but we'll come back to it in a second. We're going to write down question 7. So this is coming from the slope. Oops. From the slope. The accepted value for G, this is the constant of proportionality. Note that it's capital G. It's a big G. It's not to be confused with little g 9.8. Not to be confused with that at all. In fact, this thing, let me tell you the name of it here first. Whoa, hi. The name of it is the Universal Gravitational Constant. This value is the value you can always use when finding forces between any two massive objects. The value of this constant is 6.67 times 10 to the negative 11th. 6.67 times 10 to the negative 11th. Now you might be saying to yourself, what are the units on that? We're going to figure them out in just a second. But before we do that, let's go ahead and write down the whole formula. So this is the thing you're going to put the big box around in just a moment, but let's write it down here. Fg, the force of gravity between any two massive objects, is equal to big G, that's the universal gravitational constant, that's the slope that we found, okay, times the proportionality stuff we found before, m1, m2 over r squared. I think on your equation sheet it's listed as an r. Yep, and it is in your book as well. I think we had been writing it as d for distance. You can also talk about it as r for radius between two things. They mean exactly the same thing. I'm used to writing r, so that's how I'm going to write it. But if you like d better, then by all means, make yourself happy. Let's figure out the units here real quick. What are the units for a force, friends? Newtons. So newtons equals something. There's some unknown units there. What are the units for a mass? Kilograms? For both of them, right? What are the units for distance? Meters? But they're squared. This thing is like kilograms squared, right? Because there are two of them. So the game here with this funny constant is that we have to multiply kilograms squared divided by meters squared and somehow get newtons out of it. Seems like a goofy plan. Let's just literally do it. I want to get what out? What's my goal? Newtons. I'm trying to get rid of meters squared that are on the bottom. How do I get rid of meters squared on the bottom?
On top.
Put it on the top. All these skills that we learned early on in the year, they're coming back. How do I get rid of kilograms squared on the top? Put it on the bottom. And this right here, my friends, these ugly units are the units for big G. It's a Newton, meter squared per kilogram squared. Okay. Great, Miss K, you say that's awesome. I'm so glad we just did that. Why do I care? Yeah. Okay. So should flip your paper over and look at the very top. There are two questions at the very top. They are going to motivate the next few minutes of our conversation. The questions say, or the statements, or the whatever. A force is an interaction between how many objects? Two. Always two. And the gravitational force acts between any objects with what? Mass. Now, when I was planning this conversation with you, I was hoping that it was going to happen last week. But, times don't work out. The reason I was hoping that it would happen last week is that there is a life lesson and opportunity that I want to share with you that would have been perhaps particularly appropriate for some of you to have had the conversation last week. Because last weekend I saw many of you here Saturday night. You show up at school on a Saturday night? Why would you do that? For prom. Right? Prom season is here now. There's lots of fun things that happen for prom, right? You can get all gussied up and you go out to dinner, blah, blah, blah. But one of the things that may be a little bit scary about prom season is that socially expected thing that not everybody does, and I have a lot of respect for that, but not everybody does this, but some people feel the need to find a companion to go to prom with. Whether a friend or, that person that you've just been observing from afar for many, many years. I don't know, whatever it is. But I am here today to help you. Now, I realize that prom already happened, and so you either went for it without my advice and help, or maybe you didn't. And for whatever reason, you're still looking for a little bit of something from me, and I'm here today to give that to you, okay? If you were a little bit nervous and you just didn't know, and oh my God, I don't know, they're just so intimidating, and I don't know. Today, right now, you ready? Okay. This is the opportunity, this is a way to break the ice. Because maybe you've been admiring this person from afar, and you're like, you just don't know what to say when you go up and talk to them. So this is what you can say. You can say, hey, I just wanted to let you know that I'm attracted to you. Right? But not only, no. Let me sell you. Hold on, I'm almost there. Not only am I attracted to you, question 4 says it's an attractive force, right? But this is the more important part. This is the more compelling part, and this is why that person may just be convinced. Because not only am I attracted to you, but you're attracted to me too. The same amount. Isn't that great? We're both attracted to one another. And that, my friends, will probably do one of 4 things. Either they will think that you are a little bit strange, and then realize that you're a lot strange, but you're lovable and wonderful, and so they should hang out with you. That's option number 1. Option number 2 is that they have to scratch their heads for a little bit, and then maybe they get it. Option number 3 is that they've heard of this idea, right? In which case, like maybe this whole idea of if I'm attracted to you, you're attracted, sure, maybe that, and so maybe that'll warm their hearts and love will blossom and it will be a beautiful thing. And maybe it's just friendship. I want to make that clear. I'm not trying to get you to find the partner that you're going to live with forever. I'm not trying to imply that. Or, and this may be both the best and worst of options. The other person has realized this and done the math as well. And then they might realize that the force really isn't that big. But if that's the case, then they're probably nerdy enough that you want to hang out with them anyway, right? Because they've already done the math.
Plus, they're attracted to everyone else.
What's that?
They're attracted to everyone
else. There are some details that we don't want to get into. But really quickly before we go, because I want to make sure that you've got this all in your brain and you understand this. And friends, I really think that this could be the next new thing, right? I think that this could work. So you have to let me know when it's successful. You're going to send me an email and in 5 years be like, Miss K, you won't believe it. Blah, 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 blah. I'm getting married, blah, 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 blah. And it works, right? That's what's going to happen. But before that, let's do the math. A 50-kilogram person and a 75-kilogram person are sitting on a bench 3/4 of a meter apart. I would like for you to find the magnitude or the size of the gravitational force that each of them exerts on each other. Okay? Do you have everything you need in order to do this problem? Yes. I think you do. Go ahead and do it. Person A. There's person B. They're sitting on a bench. So friends, do you agree that there's a force that B is pulling on A? It's my person. I just don't draw people well. Why don't I? Oh, I thought she was criticizing my people drawing skills. There's an attractive force there between every 2 massive objects. Now, you probably don't want to say that. Hey, I'm attracted to you because you're a massive object. That probably wouldn't go over well. But I really believe in this, you guys. I think this will be good. I have gotten you to appreciate great humor. What's the answer? What did you get? Is it big or small? It's like 4 point something, right? 4.5 times 10 to the negative 7 or something like that? Physicists, please make sure that you work on these 3 problems before you come to class tomorrow. Page 234, questions 1, 2, and 3. Would you also please put any physics books away that are on your table? I would very much appreciate that. We didn't have time to go through all those other problems. That's okay. There we go. Have a great day, you guys. I'll see you tomorrow. Be well. Yeah. Yes, hold on.